Okay, well, remember where our place was before we had this definition. We were here. We were trying to find our estimated regression coefficients. So we had x star t, x star t, y star. And we're going to do this by looking at this first and then this, okay? So first of all, what's x star t, x star? Well, this is just equal to, we just flip this on its side. So I have x 1 star, x 2 star, right, all the way down. So x n1 star. And here I have x 1p minus 1 star, x n p minus 1 star. And now just the regular one, x1 star, x n1 star, x1p minus 1 star, x n p minus 1 star, like so. So this result is p minus 1 by p minus 1. I can see, and what is each entry? So this is p minus 1 by p minus 1 when I'm done. And say find the, what is the k row else column of the product is, well, I would take the kth row here, right, and take the dot product with the else column here. So this is just the sum, I equal 1 to n. Kth row, let's see, that's the second index here. So I have x I k star times, and the else column is also the second, the column is the second one here. So I have x I l star. And if I use the regular definitions back to the original variables, I mean, this is equal to the sum I equals 1 to n. Okay, and think about what each of these is. I have xik minus x bar k over the sum xjk minus xk bar squared times xil minus xl bar over the square root of sum xjl minus xl bar squared. And these are constants, so they come outside, and the summation is only up here. So this is actually equal to, can you tell me what this is? This is just the correlation between the xk column and the xl column. So this is equal to correlation xk xl, or we can use this notation to r kl. Okay, so if I do this for every element, then I can see that the x star t x star matrix, which is p minus 1 by p minus 1, should be equal to this. It's going to have 1s on the diagonals because those correlations are 1, as you can check. And the off diagonals are the correlations between the whatever the row and column is of the predictor columns. So R12, I'll put the lower number first each time. So R12, this would be R13, etc. And R1 P minus 1 and R1 P minus 1. What would this one be? This would be like R2 P minus 1, etc., right? So these will tell me how the predictors are correlated. Okay, now remember, this is for the original variables. Note, this correlation is for the original vectors. Xk, not xk star, but xk and xl. Okay, all right, so that's that one. Also, so that tells me what where the hell did it go? That tells me what this is. This is just, I'm sorry, this should be inverse, right? Good Lord. Okay, so did I mess this up before? No, it was right before. So just there, I left the inverse. Right, I multiplied by the inverse to get this solved. Now, for this one, so very interesting. I have the inverse of this correlation matrix between the predictors for the first thing. For this second thing, it's a little simpler. So, but it's also a correlation. So for y star, and we'll give this a name too. So we'll call this matrix RXX. Now for this one, it's going to be similar. We just have this is equal to, again, I have x11 star, x1p minus 1 star, and I have y1 star, yn star. And if I do the dot products here, I get, because of these stars here, again, as you can convince yourself, for example, if I want the kth element here, this is just going to be equal to r1y dot 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 rp minus 1y. I use the subscript y instead of the number to mean it's the correlation. So where rky equals the correlation of xk with y. Okay, as you can show. All right, and from the exact same reason, right? So, for example, rky is equal to the sum I equal 1 to n x ik y I, and these are starred, which is equal to summation. And now I substitute in here, I have I xi minus x k bar all over xjk, sorry, xik minus xk bar, xjk minus xk bar squared, and I have okay, so this is equal to the correlation xk and y. All right, so we have summary. We have B star is equal to RXX inverse times R, and we'll call this vector RYX. Okay, so this vector is called RYX, so we're calling this RYX here. Now this is equal to this. So it's the product of this inverse correlation matrix times this correlation matrix of x with y. All right, well, just a little more to go, but I'm going to stop this lecture here, and then we have one more with an example. There'll also be some R demo too on this, and then we start multicollinearity. So just one more on this, and possibly an R demo one too, now or later. Thanks.